Hector here from helpmegraduate.com. Now we're going to talk about limits and using the method of the conjugate, okay, multiplying by the conjugate. And again, like I mentioned in the video of solving limits using the change of variable, there isn't really like a straightforward way to know which method am I going to be able to use depending on the exercise that I have. It's just a matter of practicing and being able to realize when I have the function, when I have the exercise, of all the alternatives that I have, of all the varieties that I have, which method is likely to help me the most. Okay, that's pretty much what it is. So it's a combination of both practice and expertise and intelligence. Okay, so you have to do a lot of exercises and do a lot of problems to see and to train your eye and your brain to work accordingly once you see a problem. Okay, the conjugate is a very interesting method, and all it does is it works on getting rid of the indetermination by adding a factor that you can lose in the function. And I know it sounds a little bit complicated, but we will see that in exercise. Okay, the main theory is that, let's say we have a function, and the function is like a division, like a numerator and a denominator, and let's say we have in the upper part something that says x minus a, or something in that area, okay? And then we have at the bottom, we can have whatever expression we think, okay? It can be a radical, a complicated thing, but we may see in like the horizon that complicated expression may share something with the numerator, okay? Like a factor or something like that. It's just that we have to rewrite it or rearrange it so that the factor can appear, okay? So, when you hear factor and notable products, you're going to see something like this, okay? Keep in mind these properties, okay? X minus a times x plus a is equal to x squared minus a squared. That's pretty much what we're going to be using in most conjugate limits, okay? There's going to be another expression, but I'm going to show that to you in the next video, okay? So for now, let's do an example so I can visualize this wording more into practice, okay? Yes, you can see I'm more of a practice guy. So let's pick an example from my preferred book, and let's see what can we find, okay? Let's see. All right, I like this one. Yeah, that one should work. It's not too hard, but it's not too easy, but it should be able to help you visualize the concept, okay? Let's say we have limit of x turned into 7, and we have a function which is 2 minus square root of x minus 3 over x squared minus 49. This is the exercise. They're asking us to find the limit on that function, okay? Well, the first thing that you should do, if you correctly recall, is evaluate, okay? We cannot just jump in right away and solve the limit without verifying that indeed there's an issue with the limit, okay? So let's do that first. Evaluating, we're going to have 7 goes right here, okay? 7 minus 3, 4. Square root of 4 is 2. 2 minus 2 is 0, okay? And right here at the bottom, 7 squared is 49, minus 49, 0. So if we evaluate, we can note that right here. If we evaluate, we result in an indetermination. Zero over 0. So that means that we have to simplify, solve, do whatever magic we can to get rid of the indetermination. Okay? So, let's see. Here's our function. Well, the first thing that you're going to ask is, how do I multiply by the conjugate? What is the conjugate? Okay? Well, first of all, think about it. Just your normal life. Let's say you have two problems in your normal life. One is easy and one is complicated. Which one would you likely get rid of first? Well, I don't know about you, but me, I would like to get rid of the complication, okay? Because the easy problem is just easy to solve, okay? The complicated is just complicated, okay? The same reasoning applies for here. We have two expressions right here. We have 2 minus x minus square root of x minus 3, and at the bottom we have x squared minus 49. So which one sounds more complicated to you, the upper or the lower? If you said the upper, that's true, right? We have a radical. Okay, that's the complication. So let's see if we can get rid of that radical. Okay? Now, the question is, how do we get rid of the radical? Well, let's erase this. And that's where the conjugate is going to come into place, okay? The conjugate is just simply multiplying by 1. It's just that the 1 is re-expressed as something else, okay? So let's say if I multiply that for something like an example, okay? This is not the answer, but I'm just giving an example. Something like 8 over 8, am I affecting the function in any, in any way? No, because 8 over 8 is 1. I'm just multiplying this by 1. If I multiply this by, say, something like cubic root of x squared over cubic root of x squared, am I affecting the function in any way? No, this is just 1, okay? Of course, I have to multiply it by the conjugate of the expression I want to get rid of, okay? Which we said is the radical. That is the expression we want to get rid of, okay? That's the complication. So, if we visualize this 2 minus square root of x minus 3 as this, okay, I'm going to make a parenthesis right here, 2 minus square root of x minus 3, we're going to visualize exactly like this. So that means that this right here is going to look like x, and this right here is going to look like a. And we're going to have x minus a, and the conjugate is going to be the positive one, x plus a. So how do we write this into this? Very simple. The conjugate of this is going to be 2 plus x square root of x minus 3. Okay? And this right here is what we refer as the conjugate. Okay? As you can see, x minus a times x plus a. This is the same thing as doing this. 2 minus square root of x minus 3. 2 plus square root of x minus 3. Okay? Each element is associated. Okay? And now, so that we don't affect the function, we are going to multiply the function by the conjugate upper and lower. So we're going to have 2 plus square root of x minus 3 over 2 plus square root of x minus 3. Okay? We just multiply by 1. And this one right here is what we refer as the conjugate. Okay? Now, how is that going to help us solve the limit? Well, just give us a few minutes, well, seconds, and you'll see. So, if this expression is the conjugate of this, and by using this property, I can rewrite the upper part of the function like this, okay? So, I'm going to make a note right here, and state that 2 minus square root of x minus 3 times 2 plus square root of x minus 3, this is going to be equal as 2 square minus square root of x minus 3 squared. Okay, it's just a notable product. So let's rewrite the function. Limit of x tends to 7, and on the upper part I'm going to have 2 square minus square root of x minus 3 square. And at the bottom, I'm going to have x square minus 49 times this, because I have to multiply the bottom 2 plus square root of x minus 3. Is that helping at all? Well, not yet, but just give us a second, okay? Let's rearrange the function, the limit, one more time. What is it that we can rearrange? X squared minus 49. This right here. According to this product right here, this little equality. We can rewrite x squared minus 49 into its both factors. So let's do that. X minus 7, and let's write the other one over here, x plus 7. Okay, we just rewrote it and rearranged it, that's it. Can we do something else to the function? Yes, of course. How much is 2 squared? 4. And can I do something to the radical? Radical of square root minus 3. Square, well, the square cancels the radical, so it goes away. So long, square root. And I end up with that. The radical went away because square root of radical is the argument. Minus x minus minus 3. So this ends up looking like this. Minus x and then plus 3 already. See? Is that helping at all? Yes, of course. We have one more thing to do. 4 plus 3 is 7. So we can rewrite this as 7 minus x. Almost getting there. We can rewrite this to look something a little bit like this. We can extract the minus 1 common factor, and this is rewritten as minus x minus 7. Whoa! I can now get rid of the indetermination because this cancels this if x is not 7, which indeed is not. Okay? So, I got rid of the indetermination. Now I can rewrite the limit. Limit of x tending to 7. I end up with minus 1 on the numerator, and at the bottom part I end up with 2 plus square root of x minus 3 times x plus 7. Since I got rid of the indetermination, I think it's fair that I can evaluate. On the upper part, I will have minus 1, and on the lower part, I will have 7 minus 3, 4, square root of 4 is 2, 2 plus 2 is 4, and then 7 plus 7, 14. 14 times 4 is 56. And that is the answer to the exercise. Okay? All I did was multiply by the conjugate, 1, right? The complement of this expression following this rule right here. Okay? When I did that, I ended up with 4. We got rid of the radical. We changed the sign because we did a common factor. And that got rid of the indetermination. As you saw, remember what I mentioned at the beginning? That the numerator will share a factor with the denominator or vice versa. Well, here was the sharing. Who would have thought that x minus 7 was going to be shared factor of the upper part? See? Once I got rid of that, I just evaluate, and there we go. That is the answer to the exercise, okay? Following this rule right here, okay? And this rule right here. Next video, next exercise, and we're going to see a little bit of detail with that different conjugate, okay?